All right, so we're talking about rational functions and expressions. When we talk about a function, we're using that notation of f of x or p of x. Let's read this definition. A rational function is any function which can be written as the ratio of two polynomial functions. Okay, so a ratio just means a fraction. And there's two polynomials, so that means there's a polynomial on top and a polynomial on the bottom, where the polynomial in the denominator is not equal to 0. So we're just saying that we can't have 0 in the denominator. That's very important, right? When we have 0 in the denominator, it's called undefined, right? Not 0, but undefined. Okay, so these are some examples of rational functions. F of x equals x plus 3 over x minus 4. There's a binomial on top and a binomial on the bottom. The next one is f of x equals x squared plus 3x over 2x squared minus 5x minus 12. On top is a binomial, 2 terms, and on the bottom is a trinomial, 3 terms. All right, let's do our first example. And what we want to do is just evaluate. Okay, so here's our polynomial. Here's our rational function. F of x equals x plus 3 over x minus 4. Find f of 3. So all that means is that everywhere you see an x, you're going to plug in 3 and then simplify it, work it out. Okay, so put a 3 on top and a 3 on the bottom where the x is. So 3 plus 3 on top, 3 minus 4. Then what does that give us? 6 on top and negative 1 on the bottom. And 6 over 1 is negative 6. That's it. That's f of 3. Some people make a mistake and try to divide by 3 now on both sides. That would be incorrect. It's just a notation saying we have a function and we're plugging in 3. Okay, so for part B, same thing. Pause the video, work it out, plug in negative 2 everywhere you see an x. Okay, so negative 2 plus 3 on top, negative 2 minus 4 on the bottom. Okay, so negative 2 plus 3 gives you negative 1, and negative 2 minus 4 is negative 6. It does not reduce, but we can't get rid of those two negatives, so 1 over 6. Okay, one more. This time plug in 4. 4 plus 3 on top, 4 minus 4 on the bottom, 7 over 0. And what's 7 over 0? Right, undefined. If you write 0, it would be incorrect. You must write undefined. Anytime you have 0 on the bottom, it's undefined. If it was 0 over 7, that would be 0. Okay, so let's talk now about finding domains of rational function. So domain. To find the domain of a function in an equation form, we have to notice what values can legally replace x. It is illegal to replace x with any value that would cause division by 0. So what we're trying to do is figure out what numbers we could put in for x without getting a result of undefined. Okay, now this is just for rational functions. There's many other types of functions. But on this video right now, we're focusing on rational functions, fractions. Okay, so let's think about that last example. What number caused the denominator to be equal to 0? Okay, so this was our function. F of x equals x plus 3 over x minus 4. Only x equals 4. It's the only number that would make this function undefined. Isn't that right? Any other number you plug in for x, it's going to give you an answer, except for 4. 4 is the only one that's going to make it undefined. There's no other number. You can plug in anything you want. There's no other number that will make it 0 on the bottom, except for 4. All right, so we want to try to make a procedure out of that. We'll do that. So our domain of this rational function is all real numbers except 4. Right, so we're just saying all real numbers. You could plug in anything you want, and you'll get an answer that's not undefined, except for x equals 4. Another way of writing that phrase, all real numbers, is using this symbol that looks like an R. Another way of writing it, that R is, usually we use 2 vertical lines for the long vertical line, and then just a regular R if you're doing it by hand. This is a symbol that the computer gave me. So you could write that symbol, this R, and it means all real numbers, comma, x not equal to 4. All right, so you could write it in words, or you could use symbols to describe our domain. All right, so let's do a procedure now. What we're going to do, there's 2 steps, just 2, you can do it. First step, set the denominator equal to 0 and solve. That's our first step. Set it equal to 0 and solve. Step 2, there's actually 2 options here. You could write in words all real numbers except x equals whatever you got from step 1. Or you could write with symbols, the all real numbers symbol, comma, x not equal whatever you got from step 1. Okay, so here's our example. Find the domain of f of x equals 2x plus 7 over x plus 3. All right, so what are we going to do? Well, let's read the directions again. Set the denominator equal to 0 and solve. Which one of these is the denominator? Right, the x plus 3. Well, what about the numerator? It doesn't say anything about the numerator, does it? No. So just leave it alone. Don't even worry about it. All we care about is the denominator. Okay, so here's our denominator, x plus 3, and put equals 0. And now solve. Subtract 3 on both sides, so that gives you x equals negative 3. Are we done? No, that was just step 1. We're halfway there. We don't want to get half credit, do we? So now we want to write all real numbers except x equals negative 3. So just simply write it. All real numbers except x equals negative 3. Or we could use that other notation. The all real numbers, x cannot equal negative 3. There's also another way. You could also use interval notation. I didn't put that on here, but that's another method if your teacher desired that method. Okay, that's it. We're all done with this problem. Let's move on. Another problem. Find the domain of this function. Why don't you go ahead and pause the video and work it out, just like the last example. Okay, 4x minus 9 equals 0. Add 9 to both sides. Then divide by 4. So you get x equals 9/4. Again, the numerator, you could ignore it. Now we write our answer. Either one you want to put. All real numbers, x cannot equal 9/4. Not too bad, right? Okay, here's our next one. Oh, a little bit more complicated, right? Well, the last chapter we covered, we did a lot of factoring. Hey, guess what? More factoring, right? It doesn't go away. It's one of the great things about math. It just keeps building. I know. I love it too. Okay. Step 1. Set the denominator equal to 0. Again, the numerator, nothing. Okay, so we got to do some factoring. This is a trinomial. There are several methods of factoring. On these videos, I tend to use a lot of factoring by grouping, sometimes called the AC method. But if you want to just put the numbers in, that's fine. Okay, multiply the first number and the last number. Maybe a little review of factoring. It's a negative 30. 3 times negative 10. List all the factors. Now the last sign's a minus, so we're looking for the pair that subtracts to be 13. Some people would use 3 and 10, but that would be wrong, right? 3 and 10 subtracts to be 7. 2 and 15. Yep, that's it. And we want its sum to equal negative 13. So that would be positive 2 and negative 15. So split the middle term into 2 terms using that pair that we just found. Factor x from the first pair and negative 5 from the second pair. So we factor out an x from the first pair, that will give you 3x plus 2. How about the second pair? Negative 5, right? It's got to be negative because the first term is negative. That also gives you 3x plus 2. That tells us that we're on the right track. If those two binomials don't match, then we've made a mistake. All right, so that'll be 3x plus 2 times x minus 5. We factored it. Bring down the equal 0. Now set each factor equal to 0 and solve each equation. So first subtract 2 on both sides. That gives you 3x equals negative 2. Then divide by 3. X equals negative 2/3. And the second equation, add 5 to both sides. So x equals 5. So this time we have 2 answers. So you're going to write our answer as all real numbers. X cannot equal negative 2/3 and x cannot equal 5. So that's how you would want to write it. All real numbers, comma, x not equal to negative 2/3, comma, x not equal to 5. Okay, so notice this problem did have factoring of a trinomial. If you haven't mastered factoring yet, you want to probably go back and watch some other videos on factoring before you even try this section. If you do not know how to factor, this chapter is not going to work out well. So you have to know how to factor before you can tackle this chapter. All right, let's move on. Okay, here's our next example. Again, finding the domain. What do we do with the numerator? Nothing. About the denominator? Right, we set it equal to 0. Okay, it's a binomial. They're not perfect squares or perfect cubes. Now let's go back to our basic steps of factoring. The GCF is 3. I should have asked if it's in order. It is in order. So we go next to factoring out the GCF, which is 3. So by the way, if you're having trouble with factoring, the previous chapter was on factoring. Make sure you know the previous chapter before moving on to this chapter. Just kind of a warning, this whole chapter that we're doing right now is all factoring. Okay, so let's move on. So factor out of 3. Divide both terms by 3. That gives you x squared minus 25. That's a difference of 2 squares. A squared minus b squared factors to a minus b times a plus b. So this will factor too. X plus 5 times x minus 5. The order doesn't matter. Okay, so set each of our factors equal to 0. 3 equals 0. X plus 5 equals 0. X minus 5 equals 0. Right, the first one doesn't make any sense, right? 3 doesn't equal 0. So you could ignore that one. Solve the other two equations. The second one will give you x equals negative 5, and the third one will give you x equals 5. So we have our domain. All real numbers, x cannot equal negative 5, and x cannot equal 5. All right, so we're done with domain now. Again, that was just domain of rational functions. Now we're going to talk about simplifying rational expressions. Here's example 6. We've done a problem like this previously with exponents. We didn't call it a rational expression, but it is. Rational just means it's a fraction. And this is a fraction. Okay, so we could reduce the 24 and 36. That would be our first step. Let's see, 12 goes into both of those, right? Yeah. 2 and 3. Okay, so now let's use the quotient rule. It's the quotient rule for exponents. We could subtract the exponents. We could do it a couple of different ways. I like to subtract the exponents, the larger exponent minus the smaller exponent, and then just keep that exponent where it's larger. All right, so look at the x's. There's 5 on the bottom and 3 on the top. So which one has more? Right, the bottom one, right? By how many? By 2. So there's 2 more x's on the bottom. How about the y's? Which one has more? The top. By how many? By 6. So that's our answer. So we have 2 over 3, and there's y to the 6 on top and x squared on the bottom. Again, you subtract the exponents, larger minus the smaller, and then keep it where the exponent was larger. Okay, so what we're doing is we're simplifying a fraction, we're reducing it. You know, the 24 is 12 times 2, and the 36 is 12 times 3. We could have wrote it out horizontally and then canceled out the 12s whatever's the same on the top can cancel with the same thing on the bottom. All right, let's move on. Okay, some rules. Simplifying rational expressions if the numerator and or denominator has more than one term. So that last example, the numerator and the denominator only had one term. So now what about if there's more than one term? Step 1. Factor both numerator and denominator of the fraction. Factoring, right? It's a big part of this class. And it never goes away. You have to know how to factor. Even if you go on in other math classes, if you take trig or calculus, you definitely need to know how to factor. Okay, step 2. Reduce the fraction. To reduce the fraction, cancel out or divide out like factors in the numerator and denominator that are exactly the same. Step 3. Rewrite any remaining expressions in the numerator and denominator. So that just means just write it down. You don't have to multiply, just write them next to each other, usually in order. Numbers go first, then variables, then binomials. All right, let's do an example. X squared minus 7x plus 12 over x squared minus 16. So what do we need to do? We need to factor both numerator and denominator. So the top, that factors to x minus 4 times x minus 3. And the bottom, that factors to x minus 4 times x plus 4. You might have wanted to write them separately to work it out. I just kind of put the answer right there. But you might want to put that to the side of the problem. Factor the first one. List all the factors of 12. There's 1 and 12, 2 and 6, 3 and 4, and then 3 and 4 3 and 4 add to be negative 7. And the bottom one, x squared minus 16. That's a difference of 2 squares, x minus 4 times x plus 4. Okay, so now divide out like factors. Is there anything that's the same thing on the top and the bottom? Yeah, the x minus 4. So you could just cancel those right out. Now what's left? An x minus 3 on top and an x plus 4 on the bottom. You don't need to leave it in parentheses. There's nothing to be multiplied by it, so that's our final answer. Okay, here's our next problem. Again, you might want to pause the video. You're going to factor the top and factor the bottom. All right, maybe we'll do a better job here. Let's work on the first one. 9y squared minus 1. What is that? How do we factor that? Right, that's a difference of 2 squares, right? They're both perfect squares. One will be plus, one will be minus. So that's 3y minus 1, 3y plus 1. Okay, let's work on the denominator. Multiply the first number and the last number. Three times 4 is 12. Which pair will subtract to give you 12? I'm sorry. Which pair will subtract to give you 11? Right, the 1 and 12. And then what signs are we going to use for the 11? We want to use a positive 12 and a negative 1. Yeah, that'll give you a positive 11. Okay, so rewrite the terms. Now factor out a y from the first pair and a 4 from the second pair. So we should have 3y minus 1 times y plus 4. Okay, so the last example that I didn't write them separately. Some people like to do it separately first, work on one problem at a time. Some people could work on both of them at the same time. Work it out with whatever method works for you. Okay. I kind of think it's better to work out these problems on the side, but if you don't need to, you don't have to. Okay, so rewrite it. The 3y minus 1, 3y plus 1 goes on top, and the 3y minus 1, y plus 4 goes on the bottom. Now we can cancel. Anything cancel? Yes, the 3y minus 1s. And so whatever's left is our answer. Okay, here's another one. These trinomials, a little bit more complicated, but it's the same process. Notice that it's to the fourth power. The trinomial is to the fourth power, but the middle term is half of that. So you could still do the factoring by grouping. The only difference is that when you do your middle terms, they're both going to be x squared terms. All right, let's do it. So let's do the top first. Oh, you might want to label each of them, top and bottom, so that when you put your factors back into the fraction, you don't forget which one goes where. All right, so 6 times 4 is 24. And we want the factors that will give us an 11. Which pair will it be? Yeah, the 3 and 8. Both negative. Right. Factor out a 3x squared from the first pair and a negative 4 from the second pair. Okay. Remember to pause and work it out at your own pace. Right, so the top will be 2x squared minus 1 times 3x squared minus 4. So that's the top. Now we've got to work on the bottom. 6 times 4, still 24, negative this time. So it's still the same pairs. This time we want to find the pair that subtracts to be 5. Interesting, right? It's still going to be the 3 and 8. Yes, but this time they're going to be different signs. A positive 3 and a negative 8. Okay, same process. 3x squared from the first pair, negative 4 from the second pair. So this time it's a 2x squared plus 1 times 3x squared minus 4. All right, we're almost there, right? But the first result on top and the second result on the bottom. Now what cancels? Right, 3x squared minus 4. And we're all done. 2x squared minus 1 over 2x squared plus 1. We can't just cancel out those 2x squareds. A lot of people will try to do that. It's got to be the whole factor that cancels out. Likewise, some people will make the mistake on trying to cancel from the very beginning, thinking, oh, I could cancel out those 4s and those 6s. Yeah, that would just be wrong. You don't want that. Okay, so you have to factor and then you can cancel. All right, example 10. All right, let's do the top first. 8x cubed plus 125. This problem is the sum of two cubes. And I'm sure you have this memorized, right? What's our formula for the sum of two cubes? Yeah, there it is. A plus b times a squared minus ab plus b squared. And our a is 2x, and our b is 5. See, these are perfect cubes, so we want the cube roots. 2x times 2x times 2x is 8x to the third. And 5 times 5 times 5 is 125. And then we had two formulas. One formula for the sum of two cubes, that's this formula. And one formula for the difference of two cubes. Okay, so now we just follow the formula. It says a plus b. So that'll be 2x plus 5. Okay, now the second part, it says a squared. Well, a is 2x, so that means 2x times 2x, 4x squared. Then a minus, because there's a minus in the formula. Then it says a times b. 2x times 5 will be 10x. Then a plus, because the formula says plus. B squared, b is 5, so 5 times 5 will be 25. That's it, we're done with the top. All right, let's move on to the denominator. Let's see, it's not perfect cubes, not even perfect squares. What are we going to do? Let's see, basic steps of factoring. Number 1, is it in order? Yes, it's in descending order. Number 2, is there a GCF? Yes, there is a GCF. What's our GCF? Right, 3. So factor out of 3. What does that give you inside the parentheses? 4x squared minus 25. 4x squared minus 25, now what is that? Oh, that's a difference of two squares. 2x plus 5 times 2x minus 5. Okay, that's the denominator. Put it all together. Is there anything that we could cancel? And by the way, sometimes there's not. And then you just leave the fraction the way it was. You know, just like in arithmetic, if they gave you a fraction, let's say 15 over 22, and they said reduce it. Well, 15 over 22 doesn't reduce. Or if I said 4 over 9, that doesn't reduce. Okay, so what cancels here? Just the 2x plus 5s. So now just rewrite everything that's left over, and you do not have to multiply the 3 on the bottom. You can, but normally we just leave it in factored form. You don't have to distribute anything. All right, we got a couple more examples, so hang in there. Okay, number 11. Factor the top, factor the bottom. Okay, we're going to use grouping. There's already 4 terms. So what do we factor from the first pair? An x. How about the second pair? A negative 2y. Again, you might want to pause and try to work that out. Okay, so our factors are the same, x minus 3, so that'll be x minus 3 times x minus 2y. All right, now do the same thing with the bottom. What can we factor with the first pair? We could factor out a x, How about the second pair? Negative 2b. Sorry, I said that wrong. Negative 2y. All right, so now the x minus b's are common. That goes first, and then x minus 2y. Let's put it together. What can we cancel? Right, we could cancel the x minus 2y's. And then we're all done. Again, get rid of those parentheses, so it's just x minus 3 over x minus b. Okay. So now we've got to talk about when one of these factors is in the wrong order. Okay, so we've done some factoring problems where we have an exercise and just factoring out the negative 1. And then we also talked about, well, what about if it's not in order? We have to put it in order and then factor out the GCF. And if the first term is negative, then your GCF is negative. All right, so let's read what we have here. Now, part A says write the terms in descending or alphabetical order, and B says factor out a negative 1 along with the GCF if the first term is negative. So for example, let's say we have B minus A. You rewrite it as negative A plus B, right? You put it in alphabetical order. And then from negative A plus B, you could factor out a negative 1. So then it would be negative 1 times A minus B. Okay, so let's look at this fraction here. A minus B over B minus A. The top is fine, right? So leave the top the same, but the denominator, you got to rearrange it. Sound okay? So the top is A minus B, the bottom is negative A plus B. But we can't have the first term with a negative, so we have to factor out a negative 1. So you factor out a negative 1, and that gives you A minus B. You divide both terms by negative 1. Now, the A minus B's will cancel. So what's left on top if everything cancels on top? Yeah, you have to put a 1 up there. So 1 over negative 1, that would equal negative 1. Okay, so a little shortcut. Anytime you have x minus y over y minus x, it's always going to be negative 1. So if you want to use that shortcut, and if your teacher doesn't mind, go for it. Okay, 2 more examples here. 2 more examples. So it should say simplify. Let's factor the top. So what can we factor from the top? A y. So factor out a y, that gives you 5x minus 3. How about the bottom? It's not in order. So what are you going to do if it's not in order? Right, you're going to put it in order. Now what's our GCF? Negative 3? Right. So the negative 3 goes in front. Divide both of them by negative 3. So in the parentheses, you'll get 5x minus 3. That's your denominator. Now, does anything cancel? Right, the 5x minus 3's. And then we're done. Negative y over 3. Okay, this is the last problem. The directions should say simplify. I forgot to write the directions, but we'll do it anyways. All right, let's write the top. Let's see, 28. What are the factors of 28 that subtract to be 3? Right. 7 and 4. It'll be plus 7 and minus 4. I didn't write all the list on the side. I think you're okay by now. Right at the bottom, it's 9 in order, right? So what are we going to do? Yeah, that's right. We're going to put it in order. Okay, so now it starts out with a negative x squared. We don't want it to start with a negative, so we're going to factor out a negative 1. So if you divide all the terms by negative 1, all the signs will change in the trinomial. All right, now we want to find the factors of 24 that subtract to be 2. Right, 6 and 4. And what will the signs be? It'll be a positive 6 and a negative 4. So plus 6 and negative 4. And don't forget the negative 1 in front. Almost there. So now what can we cancel? Yeah, that's right. We can cancel out the x minus 4s. So we're left with x plus 7 over negative 1 times x plus 6. The negative sign, it's okay if you leave it there, but traditionally we put the negative right in the middle of the fraction. So negative x plus 7 over x plus 6. All right, good job. You guys hung in there. I know it was a long video. See you here for the next one.